Hey everyone, welcome. My name is Caleb. I recently joined Aleo as a DevRel, and I'll be creating content on blockchain and Web3 and zero-knowledge proofs. This video is pretty much a workshop that will show the end-to-end experience of working with zero-knowledge proofs, the Aleo network, and the Leo programming language. If you're new, that's a lot of words, so we're going to do a quick overview explaining all of this, and then we'll go through the hands-on exercises showing how to create a decentralized application on Aleo and deploy that to the network. Aleo is a blockchain or a decentralized ledger, and with zero-knowledge proofs, it allows users to execute code off-chain and then finalize the result on-chain. The other major benefit of zero-knowledge proofs is that it allows for private applications. So to understand this best, we'll compare it to some things you may be familiar with, starting with Bitcoin. Bitcoin allows for decentralized transfers of value. You can send Bitcoin peer-to-peer to anyone in the world. Ethereum innovated on this by allowing arbitrary code execution on a decentralized network, allowing many decentralized applications to be born. Zcash innovated, but in a different way, focusing on privacy, with the goal of allowing users to transact privately. The idea of Aleo is that we want to have the privacy of Zcash with the programmability of Ethereum, and that allows for private decentralized applications. These are all layer 1 blockchains, meaning that they're not built on top of any other network or blockchain. They are their own blockchain. So if you've heard, for example, zero-knowledge proofs in the context of a ZK rollup, likely on Ethereum, this is not the same thing as Aleo. That's building on top of the Ethereum network, where Aleo is a completely separate chain with its own cryptocurrency. The focus of this video is going to be primarily the Leo programming language. However, we could release content in the future talking more about how Aleo works at the network level. One key component of Aleo that you should know, though, is zero-knowledge proofs. So we're going to talk about these because they can be a bit confusing, and I want to upfront explain what value they add and why you should care about zero-knowledge proofs. But to be clear, when we start programming with Leo, you don't have to know the inner workings of zero-knowledge proofs. It's all done for you behind the scenes. This section here is just to give you an introduction to zero-knowledge proofs so you know what is happening and you understand the concepts of what we're doing. A zero-knowledge proof will allow you to 100% know that some code was executed correctly. This means that users can execute code locally on their own machines, generate a proof, which is basically a token verifying they did that execution correctly. That proof will then be verified, which will basically confirm that the user executed the code locally and they executed it correctly. This offers a couple major benefits. The first thing here is zero gas fees needed, specifically when it comes to increasing the amount of computation. This is not going to increase the amount of gas used because the execution is done locally. There will still be some gas fees on the network, but any local execution is not going to consume gas. And gas is basically a fee that you pay in the native cryptocurrency of whatever network you're on, which basically prevents spamming the network with a bunch of computation. So with zero-knowledge proofs, the execution is done locally on users' machines, and we don't have to have all of the nodes in the network do that same execution. They can just verify the proof and trust that the code was executed correctly. The next benefit of that is that there's unlimited application runtime, meaning you can make these programs as complex as you wish, and you can submit zero-knowledge proofs at whatever interval you might need. There's no need to execute the code across all the nodes, so you can have a pretty complex program that's executed on a local machine and just get a simple proof sent back to the network. So those are the major benefits explained when it comes to scalability. But the other major benefit of zero-knowledge proofs, which is probably what most people are familiar with when they think of zero-knowledge proofs, is the privacy. So with a zero-knowledge proof, the input for whatever code is executed remains private. So if a user is executing some function on their laptop, the arguments passed into that function do not get exposed to the network. Instead, they will be tested against certain assertions locally, and that is all part of the zero-knowledge proof magic. We can verify that the inputs meet some condition, but we don't necessarily have to know what those inputs are. The programming language Leo will use zero-knowledge proof circuits behind the scenes to do this for you, and you can just describe what information needs to be private in your application and what information can remain public. All right, cool. So we got all of the knowledge prerequisites out of the way. You should now have a pretty basic understanding of how Aleo fits in with these other blockchain networks. and what a zero knowledge proof is and what value it adds. Up next, we're going to talk about getting started with the Leo programming language so you can use zero knowledge proofs yourself. There are two approaches to this, so we can do this in a playground environment. You can just think of this as a sandbox to test out different Leo programs, and you don't have to install anything on your local machine. Or you can set up a local environment, which I'll show both of these. The local environment that will get everything on your local computer, so you can probably build a little bit more complex applications and deploy them to the network. So if you're strictly interested in the Leo language and the language concepts, then you can go to play.leo-lang.org. And then this will have the Leo code and the inputs, and you'll see the output over here. If you instead want to install everything locally, we're going to need a few pieces of software. So we're going to need Git, we're going to need Rust. Then we'll need some tools specific to Aleo, so we will need to install Leo and Snark OS. We'll talk about those and the differences between them here in a moment. And then we'll also install various tools such as a wallet, the Leo wallet, and Visual Studio Code extension. You'll probably want to use Visual Studio Code if you need a text editor. We do have extensions for some other editors, but I'll be using Visual Studio Code in this lesson. So we're going to go through installing all of that. If you already have it ready to go, then feel free to jump to the next section. But for completeness sake, I'm going to go through that installation process because I'm on a brand new Mac, so I haven't installed anything. So this should cover most scenarios. And if you're on Windows, you might need to adapt slightly, but the overall process is going to be pretty similar. First off, we have Git at gitsem.com. We will download for Mac. You could also use tools like Homebrew, so brew install Git. So we'll start with that. Since I'm on Mac, I will install Homebrew. Copy this, and then I will open up a terminal. Okay, cool. So we will install Homebrew, and we will also get the prompt to install the Xcode command line tools, which you will need. And this will give you a variety of tools for software development. You may not get asked this if you've already done this before. And this can take some time, so be pretty patient here. Okay, looks like we have this installed. We say brew, command not found. There's one more extra step here. Run these two commands in your terminal to add Homebrew to your path. So copy this one here, paste that here, copy this one, paste that here. Now we should be able to say brew, and we get a usage response. So we can now say brew install Git. Alright, so we have Git. We should now be able to say git -- version, and here is the version I'm on. I don't think brew gets the absolute latest, but it's close enough. The next thing we're going to need is Rust, so rust-lang.org/tools/install, and we'll copy this command here, and we'll paste this, and then proceed. Once this is done, from a new terminal, you should now be able to say cargo -- version, and you'll get a version, in this case 1.72. Doesn't have to be exactly the same as mine. Everything should be pretty similar. Next up, we will install Leo. So you can install from this link here, or you can build from source. This is what I'm going to do, so I'll just copy this here. And in our terminal, we will paste. Okay, this is now done. You should be able to say Leo, and you'll get a usage response. This will be used to interact with our application. Next up, we will install Snark OS, and this will give us commands to interact with the network from our computer. And then we'll just copy this command here, cargo install Snark OS, and paste this. Alright, that is done, and you should now be able to say Snark OS and get a usage response. Okay, next up, we will need to install Visual Studio Code or some text editor. So here we are at the Visual Studio Code website, and we will install this for Mac. And then just take the downloaded file that was in the zip and drag it to your applications. And you should now be able to search Visual Studio Code and open it. And yes, open. And next up in here, if you want to add this application to your path, Visual Studio Code, so you can say code from the terminal, then you will do Command-Shift-P. This will open the command palette. I don't think this is a required step on Windows. And you can just search path and then install code command in path. Okay, and then type in your password. So now we can launch Visual Studio Code from our terminal. Next, within Visual Studio Code, you will want to go to the extensions and search Leo and get the official VS Code extension for the Leo programming language. The final tool I'm going to suggest you install is from within Google Chrome specifically. We will go into extensions and then visit Chrome Web Store, and within here search Leo and find the Leo wallet. This is a wallet that will just simplify some of the things we need to do, so I suggest just adding this to Chrome, and we'll just leave it at this page for now. I believe that's everything we have to install, and we can now start working with some of these tools. The first thing I want to do is talk about the difference between SnarkOS and the Leo commands in the terminal. These can be often used to do similar things or sometimes the same thing, but the SnarkOS command is generally going to be used to work with network, and the Leo command is going to be used to work with your application. And if something's possible with both of those, such as creating a wallet, I'm going to preference the Leo command. So to get started, we'll say snarkos --help, and this will give you some example commands, and you can dive into each one of these. So for example, snarkos start --help, and you can see a bunch of different commands for working with your node. So for example, you could set it up as a validator or approver or a bunch of other things. We're not going to do too much of this. The main thing we're going to use the snarkos command is for deploying to the network. Now let's take a look at Leo. So we can say Leo --help, and there's a bunch of commands there as well. So the very first command I want to use is Leo account to create a new account. So you'll say Leo account new, and this will give you a few values back. Now we will sometimes be working with this account through the Leo wallet extension, which you can access on this page that opened up, or what you can do is you can go into your extensions here and then pin it so it shows up right here. And from here, this will open this page. And then I'm going to create a new wallet. This will give you a seed phrase, which can be used to generate multiple private keys. I am not going to show this on video, and this is not something you want to share with anyone. Once you're done, it will automatically create your first account. So currently we have this account here with this address, and we have this account we created in the terminal. This wallet currently doesn't have anything valuable in it, but we are going to interact with our wallets, so you'll want to write down this information somewhere. I'm going to just leave it open in the terminal for right now, and I'm going to take the private key and import it into the Leo wallet app to show you that process. So you can have multiple accounts. You can take this private key and import it into your Leo wallet app. So we can drop down from this account 1 and we can import an account and paste in a private key. Import that, and now we have an account 2. So that showed you 2 ways of creating an account. You don't have to do both. The first way is to do it with the terminal, and then you'll just have the private key, view key, and the public key or the address. Or the other option is to do it within an app such as the Leo wallet, which will create an account for you. So now I want to talk about these values, what they mean. We have a private key, a view key, and an address. So the private key is for your ownership of this account. You don't share it with anyone. Now clearly I'm sharing it in this video, but I'm not planning on putting anything of value into this account. Plus, we're currently on testnet at the time of this video, so there's not anything of value to put in the account anyway. What do I mean by testnet? Well, everything we're going to be using is going to be testnet Aleo credits or testnet tokens that we create. In other words, it's for testing purposes and no real value is being transferred. Either way, you generally don't want to share out your private key. Now let's talk about the view key. Because Aleo encrypts everything and you need a way to decrypt those values, the view key is how you do that. This is still kind of a private value because you don't want everybody on planet Earth to see all of your transactions. It defeats the point of the privacy part of this. But there are certain scenarios where you might want to give out your view key to a certain application to make things easier. So share this rarely. Now the address, that's generally considered the public value. This is what you would give out to people to send funds to you. So when we talk about getting Aleo credits, we're going to use this address. And that's the same value you'll see right here, which you can copy on your 2 different accounts in this case. So these are both going to have their own address. Here's a quick preview of what it's going to look like when you want to send Aleo. You'll paste in somebody's address and an amount of Aleo credits you want to send, and then hit next and send that transaction. You could then see this in an Explorer and it'll look something like this, where one of the outputs is the value being sent to the destination address, and the other output is change, or whatever is left from your current balance, sending it back to you. So to understand what I'm talking about here, you'll need a better understanding of the record model, and we're going to get into that in just a moment. Before we get into the record model, I want to talk briefly about the account model, which you might be familiar with if you've come from other networks. In an account-based model, basically each user will have a balance of some cryptocurrency, and this balance is just recorded in a mapping. This address contains this amount. this address contains this amount, and so forth. It's basically just a long key value pair data structure. That's one major approach of storing information on chain. In a record model, you will own multiple records, and the records will contain value. When you want to send some value to somebody else, that record will be destroyed, and two new records will be created. The first one being the value you want to send to somebody, and the second one being change or whatever's left over from your original value being sent back to you. So let's say I invented some coin, Caleb coin, and I minted 100 of them to me, and I want to send you 10 of them. That transaction is actually going to give two outputs, a record of 10 to you and a record of 90 back to me. And the original value of 100 is destroyed, which this paradigm can be pretty confusing, but it has various benefits that we might get into in an upcoming lesson. But that explains why you see all these inputs and output records all over the place when you start learning about Aleo. It's because anytime you transact, you're actually destroying information in these records and creating new records. One great way to see this is with an Explorer. So you can access explorer.hamp.app, and this will give you a view into the Aleo network. And we'll talk about the general structure. So a blockchain is a series of blocks, so you can see each of these blocks are numbered. And within a single block, you have transactions. This is probably a term you're fairly familiar with. If you're wanting to send some tokens to somebody, you make a transaction. But a transaction in Aleo actually consists of transitions. So if we go inside of this transaction, we'll see the transitions. And a transition describes the movement from one state to another state. So within a transition, you're going to have the input records and the output records. And you can think of a record as the smallest data structure for storing state. It doesn't really look like much, but that's because everything is encrypted. So let's go over that structure one more time, but this time working from the inside out. We have a record. The record describes some state, the way things currently are, such as how much of a certain token you have. We then have transitions, which go from one state to another state, removing records and creating new records. We then have these transitions inside of a transaction. This will be the collection of all transitions that will be published on chain. And this goes inside of a block, which can contain multiple transactions. And then there are multiple blocks in series in the blockchain. So hopefully that gave you a pretty good overview of the vocabulary you should know. So now we have a pretty decent understanding of the concepts and we have everything installed. Let's start creating an application. So I left my keys in another tab and I'm just going to keep those there if we need them, but we did import them to the Aleo wallet. But just for convenience, I'll keep them there in the terminal. And what we'll do is first I'll change directory to my home path, and you may have a Aleo directory from when we installed stuff, which we're not going to need. I'm just going to remove that, or you can just use the Finder window and go delete it. And then I'll make a directory, so a fresh directory for all of my Aleo stuff, and I'll change directory into that. And now you will want to follow this command, which is Leo new hello. And this will create a new program called hello, and then we can open that in an editor, and I'll just do that with the code command, so code hello. And here is our project. Now we can pretty much do everything from the terminal within Visual Studio Code, so I'll just say new terminal to get that open. Okay, so let's talk a little bit about the basics here. The main important thing is inside of source, we'll have main.leo, and this is going to be where we write our Leo code. So we have the program hello, so this is the name of the program, and then we have a transition function, which will take inputs and return an output. Now hopefully the syntax is relatively familiar to you, but just if you're not familiar, this is going to be the name of the parameter. The colon will then describe the type, which in this case is U32, which is an integer. So this is taking two integer arguments, one called A, one called B, and then it's going to add those together into a C variable and return that value. And then we have some other stuff we'll talk about over here in the files, but let's just focus on this right now and running this. We'll say Leo run, and then the name of the transition function, which in this case is main, and we can put two values. And when you use an integer literal, you're going to keep the U32 on there, so that's how you would say 10, and then 5, U32 to say 5, and you get some stuff back with an output of 15 U32. So the addition worked, and that's a basic example of how you run your code. Now, just to get it out of the way from the beginning, I want to show you a very basic example of a zero-knowledge proof. This one's going to be kind of silly, but it will show you the concept and allow you to see how to work with them. inside of here, we could say assert, and there's a few variations, but I'm going to say assert underscore EQ, and that's going to assert that two values are equal. And what I want to do is I want to confirm that B is an even number. And what this means is that the zero knowledge proof can confirm it's even, but we don't necessarily need to know what the value of B is. Now, if you're just adding them up together, you could probably figure it out based on what A is. So we'll actually remove public, and I think that would work. So basically you're given two private numbers and you're guaranteed to have B even, but you're not going to know what A or B actually was. We'll just know that B is even. The first thing in here will be a call to b.rem, which will get a remainder, dividing it by 2. So when we divide it by 2, if the remainder is 0, so we can check it against it being 0, then we know it's an even number. Very basic example, but it'll show us how a zero knowledge proof may work. Then when we want to use proofs, we'll use execute. So Leo execute main, and then we'll give two numbers, let's say 3u32 and 5u32, which is not even, so this should not work. But we'll show both options with an odd number and then an even number. So when we do an odd number, it's going to do some downloading, and it says failed. 1u32 is not equal to 0u32. They should be equal. So let's try it again now with a 4. And we get this wall of text, and in here there's this proof value. So this string here is our proof, and that's pretty much the summary of all this code being executed correctly and all the assertions being valid. So if you're not able to get a proof, then you didn't provide a valid input. And this proof is not going to show what the value of A and B is. Okay, cool. So this gave us a basic end-to-end example of creating an application, running it, and then creating a proof. But I want to actually do a more complex example of creating a token, because I think a lot of you are going to be interested in that. So we will create a new project, Leo new token, and I'm actually going to put an underscore, $, random, and hopefully this will give you a random enough number, because the name of this will actually need to be unique when we put it into production, deploying it to the network. So when we do $random, I get 16607. But if there happened to be a token underscore 16607, then we wouldn't be able to deploy this. So you might want to introduce some more randomness in there, or use something that's going to be unique. But the name token is very general. But either way, we will go with this because it should work, and then code, put the name of that token, and here we have our project. I will open a new terminal and take a look at our main.leo. So to create a token, we're going to need to describe what a token looks like and then talk about how to mint a token. So we'll remove this transition function, and you can just ignore the error for right now. We will create a record called token, and this is going to have an owner, which will be of type address, and a balance, which will be of type U32. So Leo has a built-in type address, which kind of looks like a string, but it doesn't require quotes, even though it's going to have some characters in it. So that's kind of interesting. So we describe what a token looks like, and then we'll create a transition function, call it mint. And what this will do is it will take a value here of how much that we want to give to this person's balance, so the balance value, and it's going to return that new token. And then all we'll need to do is define a new token in here. So return token with an owner. The value for this will be self.caller. So whoever invokes this will receive these funds, and then balance is going to be the balance passed in. Now it looks good, but we're still getting an error, and I'll explain that here in a second. It says expects 1 inputs, but 0 inputs were found. And this is currently related to the inputs file. So we have this input described in this file of what we want to pass it as an example, and it currently doesn't match our main.leo code. So some people don't like to use input files, so I'll show you how to do it from the terminal as well. But we did see it in the previous example where we just invoked our code passing in numbers instead of defining them here in this input file. So we're not going to have a main transition anymore. We'll have a mint transition, and we're only going to have one value here, and that value we'll just define as balance, which is of type U32, and we'll give it a value of 100. So that is how you can default to a certain input for this transition function if you don't provide one in the call from the terminal. So now you can just say Leo run mint, and I forgot a semicolon after this return, my bad. So we'll save that and say Leo run mint. You can see it compiles, and we get an output here. So this is the output record that's created, and it has a balance, an owner, and a nonce, which is just kind of like a unique ID for this record. This is not currently on chain. We're executing this in a local environment. We'll talk about getting this on chain here soon. We can invoke this the same way from the terminal, passing in a value. This time we'll say 1000 U32, and that will basically use 1000 instead of the default defined in the input file. And you can see that in the balance. So this is what a record looks like when it's decrypted. The owner value here, as in who called this code, is actually going to come from this environment file. So this private key here is basically just an account generated when we created this application. It's no big deal. Basically, it just defaults you to having one address so you can invoke the transition functions. And that's going to be the owner of our new token. So you could change this private key to a different wallet if you wanted to use one, or you could transfer from this wallet to another wallet. Doesn't really matter. This is all just a testing environment, so you can do pretty much whatever you want. But currently, when you're interacting with your contract, it's going to use this account. So we talked about minting tokens. Now let's talk about transferring tokens from one address to another. We will create a new transition function here. So transition transfer, and this will take 3 inputs actually. So we'll define 3 parameters here. The first one here is going to be the receiver, which is where we want to send it, and we will use the address type for this. Next, we will have the amount, which we U32. This is how much we want to transfer. And for a transfer, we need to start with an input record. Otherwise, we're not going to be able to create new output records. And that just goes back to how the record model works. So input, we'll say, is of type token. So we're expected to pass in a token. Then we'll define the return, which is actually going to be 2 tokens. So we'll say token, token. The reason 2 is because of change. So the balance transferred to the receiver, and then the balance sent back to us for whatever's left over. So let's calculate what that change value is going to be. We'll call it balance, and this is going to be of type U32. And we'll take the current balance, so input.balance, and subtract however much we're transferring. Then we can give amount to the recipient and the balance to the current owner. So let's first define the recipient, and we'll define this as a token containing the owner, which is the receiver that we passed in, and then the balance being the amount. So that is the recipient, and now we'll create the record for the sender. So this is the change record, and this will have the owner being self.caller, whoever invoked this, and the balance being the balance variable we just created. Now, if you have the same value there twice, you can just use the balance and it'll do it automatically. Then last thing, we just need to return those records. So we'll say return recipient, comma, sender. There we go. That should describe it. And now it's just complaining about the input files. So we'll go in and describe those inputs. So we'll define a new one here, which will be transfer. The receiver is going to be an address, and we can paste a value there. Doesn't really matter. I'll just grab my address from my new account I created, paste. Then the amount we want to transfer to this account is going to be of type U32, and we'll just transfer 10 of these tokens. And then lastly, we'll define the input token. So what token are we starting with? And the syntax for this is you'll need to create a token and a semicolon. Okay, now inside of token, we'll have the owner. Actually, we'll just copy this value. So from our earlier call, it'll look like this. So we'll basically take the mint record, which will describe a token of a certain value, and we'll paste it here. In this case, the value is 100. Forgot my semicolon there. Make sure we don't have any syntax issues. If you get something saying, hey, this wrong number of values are provided, then you probably just have a syntax problem. And when we use this for the input file, we will remove these suffixes. So remove the private and public like that. Okay, cool. So we described the input. Now let's try invoking this. Leo run transfer. And it worked. So basically the response is now 2 records. The first being a balance of 10 given to this address we defined here. And then the other one is the change going back to the original address with the balance of 90. So that describes basic functionality of minting and transferring. There is a more thorough example of a token in the workshops repo in Aleo HQ GitHub if you want to check that out. What I want to do now is I want to show how you could execute this from the terminal if that's your preferred route. It's a little bit more complicated, so you might want to integrate this in a script, and we'll talk about some of that here in a few moments. So to run it from the terminal, we'll say Leo run transfer, and then just provide some values. So these will need to be in strings. So we'll take the address, copy, paste. The number can be outside of quotes, so 10U32 and space. Now for the record, we'll surround this in quotes, and then we'll just copy essentially this value, but we'll need to change it, putting those suffixes back in. So we'll paste, and you'll see it show up across multiple lines, so then you'll just go in and fill those back in. So dot public, dot private, and then dot private. And I think that's good, so we'll run it, and it looks to have worked the same way. Cool, so that's how you start working with Aleo on your local machine. If you want to deploy this, we're going to use a script for that, and it's going to make it a bit easier so we don't have to type in these complex commands in the CLI. So we'll create a shell script, and then we'll be able to just substitute in values really easily. However, before you deploy, you need to get testnet credits. So deploying requires a fee, so you need Aleo credits, the native cryptocurrency on the Aleo network, and this is going to come from a few different locations. We have a faucet. This will basically send them to you directly. You could ask someone in the Discord or any other support channels, and someone can send you some testnet credits. And I believe there is different faucet variations in the works, so we might see some of those here soon. In the meantime, we'll just check out the main faucet, which requires a phone number, so you'll need to text your address. If that doesn't work, then you can reach out to someone in Discord or reach out to me. So go to faucet.aleo.org, and then you can text this number from your phone with send 50 credits to then whatever your address is. So you'll need to get that address to your phone. So just send it to yourself in email or Discord or something like that. It's not my favoriteest faucet experience, but it will get you some credits. Hopefully we can have an improved version here soon. So for this, I'm going to use the account 2 that I imported, and I'll just rename this so I can see it. I'll just call it main. So this is going to be my main account. And then this is the address I'll use. All right, so I just got 50 credits, and you should see that in your activities. So you can also open them here. And when you open this, it'll open it in an Explorer where you can see 2 transitions, one for fees and then one for actually giving you some Aleo credits. So an interesting thing here is you can't see any information, but if you connect your wallet, it'll automatically decrypt any records. So you'll be able to see the information, and you can see here's that record data with this many microcredits, which a microcredit is just the smallest division of an Aleo credit. So this is the record we're going to want to use as an input for the deployment. So to deploy an application, you'll use snarkos developer deploy, and I'll use -- help just so we can see what this is going to look like. So you'll pass in some of these additional values. And just to make it easier to fill this out without having to get it perfect in the terminal, we will create a script. So we'll create a new file, which we can call deploy.sh. And the first thing we're going to do is create a name for this based off of our application name. So app name, we'll say token _ 16607, update according to whatever yours is. And then we'll also have our private key, which is going to be needed to craft the deployment in this command. So I will grab that from our account here and paste that here. So far so good. Now we can start crafting the deploy command. I'm actually going to paste it from my notes, and I will turn on word wrap so you can easily see it here if you just want to write it out, just to save everybody some time. So this is what it's going to look like, basically substituting in our app name.aleo and then passing in our private key. And then I just have some URLs here I didn't want to type out by hand. It's going to grab the path, which is our build directory, which is generated when we run our application. And then the record, so this is what we need to define now. So let's take a look at what a record is going to look like. So we know the general structure. We'll just need to copy that over from the Explorer, which we have right here. So copy that, paste that in the quotes, save, and we'll try to run this. We'll say dot and then space dot/deploy.sh. It's downloading some stuff. And boom, create a deployment transaction for our app. And you'll get this. This is important. This is our transaction ID. So you can take this and search that within an Explorer to get the information for that deployment. Or if you forget that value, you can just go to your Aleo wallet and this will show up in your activities. Now you'll notice my balance went down a little bit. And this is just from the fees of deploying. So you can see the total fee was 3.67, which is exactly what you would get here if you subtracted from 50. You can also go into this transition and connect your wallet. And you'll see here, this is the Aleo credits that were returned back to your account after the deployment. All right, so we got our application deployed. That is how you deploy on Aleo. But are we done? I mean, I guess it's deployed, so we're done. But if we wanted to actually use this, how do you do that? That's what we're going to talk about now. And we're still going to be using these commands in the terminal. But eventually you could build basically abstractions or software around this to interact with the chain without having to type out all these complex commands in the terminal and getting it exactly perfect. So while it seems like, oh, this is like a lot of effort to do like very simple things, a lot of this is going to be abstracted away with SDKs and other tools like that, which Aleo does have an Aleo tools site, which will show you some basic usage of the SDK. But for now, we're going to do this from the terminal. So it's going to be pretty similar to our deployment script, just slightly different. So we'll start with that and then modify it. So I'll take deploy and I will copy paste and rename this to mint.sh. Now the very first thing we're going to need to do is we're going to need to update this record because that record is now spent. We need to get our new record, which has our new updated balance. So we will paste that here. Cool. So now we got that. Won't forget to update that. And instead of SnarkOS developer deploy, we'll say developer execute. We'll have the app name and then the function we want to call, which will be mint. And then the amount, so we'll say 100 U32. And then everything else will be the same except this path. We're not going to use the path because we're not pushing any files anywhere. And I think the rest is good. So it should be pretty much the same as the deploy with those minor changes. So we'll try it. We'll mint and make sure you remember the .sh. Okay, cool. So it looks like the mint was successful. We can take our transaction ID, paste and take a look at this, and you can see we have the mint call here. So we'll explore that, connect our wallet to see what we can. And here is our balance. We have 100 of this token. So that's one of the transitions. We can also see this here, which is the fee, and we connect our wallet. And you can see this is the balance back to our account with our Aleo credits. So this was used to pay the fee. All right, we got one more step, which is to transfer this token from one account to another. Same idea, we will create a transfer.sh just so we can keep all these. And this is going to have a few more changes because we're going to need two records. One as the input, the one that currently has 100 of our custom token, and then another record for paying the fee. We didn't have to have two records in the previous example because the input record already had the microcredits. But now we're going to have a record for this one here, so we'll copy this. This is going to be the fee paying record, and this is where our change will come from. So I'll define that one as record_fee. Paste that in here. And now we'll get the record which has our custom token. So we'll go back to our transitions and grab that value here. So here's our token with a balance of 100, and we'll paste that right here. So far, so good. What we need to do now is we need to update our command here. So we're not invoking mint anymore, we are invoking transfer. Transfer is going to have the receiver, the amount, and then the input token. So the receiver will just be an address. We can grab our other address from our wallet. So wallet, and we'll switch over to our secondary account, and I'm going to rename this extra. Copy the address. Paste that here. We will transfer 10 And then for the record, we will just substitute in this value. So we'll say $ curly braces record. So that is where the token is coming from. And then for the fee, that's actually going to be here at the end. So that record's going to go here. So we'll update this to record fee. Let's test this out. We'll say transfer.sh, and there we go, it worked. All right, so here is the transaction in the Explorer. Let's take a look at the fee first. So we'll connect our wallet here. And because we switched wallets in the wallet app, it's actually going to ask me to connect on this other one, which we can, but that's not actually what I want to view. I want to go back to our main account to see our change. So we'll switch and do a refresh and connect, and now we can see this change here. So this is the Aleo credits that went back to our account. And then we'll go back and take a look at this other transition. This is the transfer of the actual custom token. So we'll connect our wallet, and we can see we got 90 back to us. And now we'll switch to our other wallet. So we'll go from main to extra, and then do a page refresh. Click this little button, connect wallet. And now we see the other record decrypted, and this has the balance of 10. And there you go. You have the basics of deploying, minting, and transferring tokens on chain. I want to show a very basic example with just some local changes of introducing a zero-knowledge proof. Within our mint function, we could introduce the receiver, so who's going to get these new funds, and this will be of type address, and this is going to be a private input. And then the owner, instead of self.caller, we could make it this receiver, so we could give these tokens to anybody. However, we don't just want anybody to be able to mint stuff, so what we can do is we can make an assertion here, so assert equal, and check that only a certain person can call this, so self.caller, and then we'll paste in an address of who we want to be able to call this, which will be my account, so I will grab my address here. So I'll paste that here. So this new code will make an assertion, which will fail if someone other than me tries to mint, and it will allow us to mint to anybody, and it'll keep that address private. So we'll update the input here real quick. We'll just need to add a receiver, so receiver is of type address, and we can just send it to ourselves still, that's fine. And then a semicolon. All right, cool. So we got all those errors fixed. Just forgot a semicolon, I'm sorry guys. Leo execute mint. Oh, and this is actually a mistake on my part. The self.caller for local is coming from the environment, so we would need to update this private key here. So I'll grab that value from our terminal and paste that here. Now we'll try this again, and it worked. So we had a valid proof. And this basically shows what happens if you try to mint this from a different account. Cool, so that's just a basic example. You could introduce that to a deployed application, but I think you guys get the idea. We're going to call it there. I just want to talk very briefly about what are the next steps. So you have a good understanding now, but you probably want to build around these ideas to make more usable software. So I would start with the SDK. So you can visit aleo.tools, and this shows different things you can do with the SDK. And these are just very basic examples, but this all comes from the Aleo SDK GitHub page. So if you want to integrate Aleo into your existing applications, you can check out the SDK. And there's a Create Aleo app too, so you can try that as well. Now the website, if you want to see how that's done, you can go into website and then, expand any of this and see what's going on. But I'm not going to dive into this too much. I just wanted to show you that this website is open source. So if you're going through here and there's anything you might want to implement in your application, you can go check out how it's done. And the last thing is if you're excited about Aleo and you want to build on it, then check out the Developer Grants program. So if you are, just getting started and you want to try something out, we have Ignition Grants, which can be $3,000 to deploy simple applications with Leo. And then we have more large-scale application grants as well. Thank you so much for watching. If you want more content, then be sure to follow me and Aleo. So I'm Caleb Curry. You can find me on most of the social networks out there. Thank you for watching. Be sure to let me know if you have any comments or questions, and I'll see you in the upcoming content.